So we're going to use that understanding of backwardsing our x and our y's to graph some stuff. Now, let's introduce something new in grade 11 just to confuse you. Look at this. Look at this little -1 up here. Okay, it is not a negative exponent. Okay, well, technically it is a negative exponent, but we're not doing like math over here. It's a name. Okay, so we would say the inverse, that's what we would say with that little notation, of f of x. I'm even going to put the words in there for you. I'm doing it. F of x. So that's how we would say this whole schmatamaroo right here. Boom. The inverse of f of x. That's what that -1 means. It does not mean we're changing this into a fraction and making the exponent positive. There's no math that happens right now. There will be math, but just wait for it. Just wait for it. Okay, so we've got this is the original function, and we are going to inverse it with the -1. All that means is we're going to switch. Oh, we're going to learn to spell, and then we're going to switch x and y. That's all we got to do. So fun brackets, because why not? You're working on a slate. This is not hard at all. It's backwards them. -8, -2. Boom. Took care of that one. Then there's a little bracket here. -2 at 0. Took care of that one. Then, yes, I'm going to the other line. 4 at 3. Took care of this one. And 7 at 4. Boom. So I'm going to graph these fancy little dots. -8 at -2. -2 at 0. 4 at 1, 2, 3. And 7 at 1, 2, 3, 4. Okay. The blue is the inverse of black. Now down here, it wants you to recognize that if we were to draw a line, a very specific line, and you need to remember this line for advanced functions, okay? You're all going, oh my God. And I'm going to do it with a mouse because let's just not embarrass ourselves. What the? More than we have to. Let's go line, that. We're going to start from that corner, and we're going to go to that corner. Okay, so if we draw this specific line, which is actually the equation of y equals x, that's our most basic linear line, an inverse is reflected through it. Look at this. This is exactly equidistant from the line as that one. This one's been reflected right there. Boom, boom. It's like it's the mirror line. Boom, boom. Woohoo! Boom, boom. Okay, I'm over it. So, reflecting the graph of a function in the line y equals x will produce a graph's inverse. You need to know this for grade 12, advanced functions. Hello, you need this. You need to remember this, okay? Because you are also going to use this concept with your oblique asymptotes. And everyone's going to say, we didn't learn about the inverse being reflected. I did, I do, I have video proof right now. Okay, example 2. Graph the inverse of the given graph. Now, we have an equation, but we also have a graph that has nice points on it. So we're just going to cheat until we win and use the nice points that are given. Could you fill in a table of values knowing that this is the base equation? Absolutely. Absolutely. Or you could go on Desmos and you could graph that and then pull up some numbers that are nice from that. But because we already have the numbers provided for us, we're going to just use them. Okay, so this coordinate happens at 0, 8. So we've got 0, 8. This coordinate happens at 1, 5. Je pense que oui. Let's hit down here. 2 at 4. 3 at 5. We're starting to get the same y values because it's a parabola. 3, 5. And we always see repeating y values, but our x values change. 40. Okay, let's inverse this. Okay, so if we're inversing, our x and our y's trade places. Boom, boom. There, 4, 2, 5, 3, 8, 4. And because, okay, we're doing it. Because I want you to see me graph this once and not doing it again, we are going to go ahead and graph this together and freestyle. Okay, let's start 8 at 0. There. 5 at 1. I can already tell it's going to be ugly. 4 at 2. 5 at 3. All right, kids, 8 at 4. Let's do this. Okay, this one should be better, but the downwards branch. Oh no. This one. Oh, no, I can't do it that way. Let's try it this way. I'm literally moving my body around the dining room table to figure out. Okay, all right. You know what? She's seen better days, but let's see if I can fudge this a little. What happens if I do something with the mouse? No, can't do it. Sorry, kids. It is, oops. Half of the battle of my life these days is fighting with technology. To try. That's as good as she's gonna get. So we have graph the inverse. So the next thing I want you to think about is the inverse of a function. So hold on. Why is this a function? Going back to the mouse. Blue, look at blue. Is blue a function? Absolutely. If we take any vertical line and we draw it, it only crosses the vertical line once, passes the vertical line test. So when we take this function and we do an inverse, will we create another function? Is it all the time true? Well, look, if we draw a vertical line there, this relationship in red fails the vertical line test. So is the inverse of a function always, there it is. These are those questions on multiple choice questions where we like to make you cry. There it is. That's the trick word. Always. No, it's not always going to. Sometimes it might. If we look back over here, we're not supposed to connect the dots, but if you were to connect the dots here, let's assume that's a straight line, you can see that blue is also creating a straight line. A function created an inverse function. Okay, that one worked. But when we had a parabola and then we inverse that one, it did not create a function. Okay, so it is not always going to be a function itself. No,